Alright, so now that we've looked at budget constraints, we're going to take a look at utility maximization. Before we begin, let's go ahead and define the term utility. Utility is the benefit an individual gains from consuming a given amount of goods and services. Now, utility is a value that is going to be measured in utils, and it can vary from different individuals. So the amount of utils I receive from consuming an amount of goods and services is going to be different than the amount of utility that you receive. But as long as we're comparing it to a specific individual, we're going to be able to analyze how they gain satisfaction from their consumption. Two additional terms we'll look at are total utility, which is the total amount of satisfaction gained from consuming goods and services, and marginal utility, which means the additional satisfaction gained. Now, total utility and marginal utility are highly related to each other. Let's look at the graphs of both. So the total utility graph is going to increase initially and then reach a maximum and come back down. What that represents is that as you consume additional amounts of a good or service, your total benefit is going to increase, but only until a certain amount. Because if I continue consuming past that maximum, I'm going to actually make myself worse off. A good example of this would be when you're eating food. Let's say you start by eating one slice of pizza and your first slice of pizza makes you very happy. As you're continuing to eat additional slices of pizza, you're going to become full as you eat more, and as you consume over your amount of being full, you're actually going to make yourself sick to your stomach. Now, total utility is going to represent the maximum amount of everything, while marginal utility is going to represent the additional amount of additional amount of satisfaction per one unit consumed. So for marginal utility, you'll notice that it's going to be a downward sloping curve and actually cross the x-axis. What we're representing here is the concept of diminishing marginal utility. Diminishing marginal utility represents the fact that as you consume additional amounts of a good or service, each additional amount is going to give you less satisfaction than the one before. Again, looking at pizza, that first slice of pizza is going to make me pretty happy, especially if I was hungry and I was really looking forward to eating some pizza. As I consume a second and a third and a fourth slice, each additional slice is going to provide me less happiness than the first slice I consumed. This is going to be present in many of the goods and services that we notice. So diminishing marginal utility is going to essentially be the the marginal utility curve is going to be the slope of my total utility curve. So when I reach the maximum point of my total utility graph, the slope is 0, and on my marginal utility graph, that's represented by where the marginal utility curve crosses the x-axis. Now, while this has been fun, what we really need to work on is how to maximize my total utility given the amount of money I have to spend. Let's look back at the consumption of tops and jeans from our previous example in the budget constraint. So we're going to look at different amounts of tops that I can consume and the total utility I receive from gaining or consuming that number. Now we'll notice that my total utility is increasing as I buy additional tops. Same with jeans. As I consume additional numbers of jeans, my total utility is rising. Now, these total utility numbers are different for every individual, and they have to be given to you. So what we're going to do is use these numbers to then map out how much total utility I can gain from consuming tops and jeans. So let's look back at the budget constraint that I had in our previous video. So this budget constraint represents all combinations of tops and jeans that I can consume given $100 that I'm able to spend. Now, if I spend all of my money on just tops, I buy 10 tops. Now, from our previous slide, 10 tops are going to give me a total utility of $300. Now, likewise, if I spend all $100 on jeans, I'm going to purchase 5 jeans. And again, from my previous slide, the total utility from consuming 5 jeans is 400 utils. Now, you're probably thinking to yourself, well, why don't you just buy 5 jeans, gain 400 units of satisfaction? Well, if I only consume jeans, then I have nothing to wear on my top, and I cannot go out just wearing jeans. So let's look at the combination of tops and jeans and how much total utility they give me. If I were to consume 8 tops and 1 pair of jeans, my total utility is going to be 400 utils. To get that, 8 tops gives me a total utility of 280, while 1 pair of jeans is going to give me a total utility of 120. I simply added those numbers together to get the 400 total utility from 8 tops and 1 pair of jeans. I can do this for every point on my graph, so 6 tops and 2 pairs of jeans are going to give me a total utility of 460. 4 tops and 3 pairs of jeans are going to give me a total utility of 480, and 2 tops and 4 pairs of jeans are going to give me a total utility of 460. Based off the $100 that I have to spend and the utility of consuming both tops and jeans, we can see that my best combination and the highest number is when we consume 4 tops and 3 pairs of jeans. Now, these is one way of solving a utility maximization problem, but this requires a lot of steps and quite a bit of graphing as well. So we do have a shortcut. The utility maximization formula tells us if we take the marginal utility of tops and divide it by the price of tops, that needs to equal the marginal utility of jeans divided by the price of jeans. So let's look at how this works in a table. So this table looks a little bit larger than the one we had a few slides ago, but we have a lot of similar information. I have my quantity of tops and my total utility of tops exactly the same as I had in my previous slide. I also have my total utility of jeans and my marginal utility of jeans like I did in my previous slide. I have a few additional columns that we're going to go over together. The first one we're going to look at is the marginal utility of tops. To calculate marginal utility, we want to look at the additional utility with each consumption. To calculate this, you take the total utility of tops, the change in the total utility of tops, divided by the change in the quantity of tops. So I am unable to calculate this for the first value because I have nothing previous to work with. I'm going to work then with my next value. So my difference in tops utility is 100 minus 0. And I divide that by my difference in my quantity, which is the difference between 2 and 0. So when I take 100 and I divide it by 2, I'm going to get my marginal utility of tops at 50. Likewise, if I have the difference between 180 and 100, I have 80 utility here, and my difference in tops is going to be again 2. So 80 divided by 2 is how we get the number 40. So I did this all the way down the column, and you'll notice that marginal utility is diminishing with each additional consumption. Again, that's showing us the diminishing marginal utility belief that as we consume additional amounts, each additional unit is going to give us less satisfaction than the one before. I'm going to do the same exact steps for jeans in just a moment. My next column in my table is giving me my marginal utility of tops divided by the price of the top. Now we'll remember that tops are going to cost us $10 each. So what I've done is taken every value in this column and divided it by $10 to reach the values in this column. So $50 divided by 10 is 5, 40 divided by 10 is 4, and likewise. If I come over here and do the same steps for my jeans, I take my total utility of 120 and I subtract the previous value of 0. And now I divide by my difference in quantity of 1. So the difference of 120 divided by 1 gives me 120. From my next values, 220 and 120, the difference is 100, again divided by 1, and that's why I have 100 in the second row. My price of jeans is going to be $20, so now I'm going to take every value in this column and divide it by 20 to gain the values in this last column. So 120 divided by 20 is where I found 6. Now from here, what I want to do is I want to find a combination of tops and jeans that are going to provide me equal value of marginal utility per dollar. So what I notice is that if I consume 4 tops and 3 units of jeans, I'm now able to maximize my utility while also spending my full $100 budget. Now, some of you may wonder why we weren't able to consume 2 tops with a marginal utility per dollar of 5 and 2 pairs of jeans with a marginal utility per dollar of 5. While I can buy 2 tops and 2 jeans, I'm only going to be spending $50, which means that, or sorry, $60, which means that I still have $40 left in my budget. I'm not spending all of my money, which means that I'm able to do better by finding a different combination that spends the full $100.